This is screencast number 5 for Laplace Transforms. In this video, I'll be walking through my integration and math steps to arrive at the answer I have gotten. The initial problem given was the bracketed 0 and t between 0 and 3, and then t minus 3 with t being greater than or equal to 3. From this, you can set up just a simple integral using the kernel, 0 to 3 e to the negative st. However, when plugging in the first part of the function 0, it makes the entire integral 0, canceling it out, simplifies it. For the second one, when plugging in t equals 3, it actually separates into two different integrals, t e to the negative st minus 3e to the negative st. This can be separated and solved through some integration by parts. The first one, anyway, integrating the second part of the integral e to the negative st is simple, straightforward. It's what the original equation is derived from. So using integration by parts, u equals t, du equals 1, and then dv equals e to the negative st, v equaling negative 1 over s e to the st. Plugging back into the integral and then finally integrating negative 1 over s e to the st dt leaves you with this final form of negative t e to the st over s, 0 to infinity plus 1 over s times 1 over s e to the st from 0 to infinity, and then 3 e to the st over s, 0 to infinity. From this is where the general Laplace transforming occurs. From here, we we basically want everything to equal 0, so we can end up with a final form that no longer has t in it, that has some form of s. So we take basically anything that makes e to equal 0. In these cases, the first two cases up front, it's anything that s is equal to less than 0. That makes the top 0, because as t gets greater and greater and greater, s is a negative number. Negative e to the negative infinity, or to a larger negative value, is 0. It goes to 0. So that's the same for both of these two. And then the last one, when taking that, leaves you with 3 over s through L'Hopital's rule. And that actually gives you the final limit as t approaches to infinity. So the Laplace transform of the initial function, two-piece function, is 3 over s, with s being less than 0.